Okay. So, good afternoon, everyone. Hope all you are doing great. So, welcome to the today's session of the use of the Docker in the machine learning project or in a data science project. So, uh, in this session, previously what we have discussed, we have gained overview knowledge of the data science, okay, of the artificial intelligence, of the machine learning. What is the workflow of the machine learning project? How we are choosing the correct ML machine learning model. Then, what are the features of the AI? Okay, all these things we have discussed in our previous class. So now, coming to the agenda. So this many things we have finished yesterday. That is the introduction to AI, then features, then what is the machine learning, okay, the life cycle of a project. Uh, so after this, today we are going to discuss about what is the Docker. Okay, what is the difference between the Docker images and the Docker container? Then use of Docker in the AI. Then benefits of using the Docker. So let's get started with our today's topic. Okay. So now, as when we are, suppose take an example, when we are talking about a machine learning project, okay, for building a AI application. So for the first instance, what we are doing, we are collecting the data, okay, we are gathering the data. Then after that, we are doing the analysis, right? We are doing some exploratory analysis. We are doing some feature engineering upon that data. Then after cleaning the data, after manipulating the data and converting or transforming the data into the correct format so that it could give me the best predicted result, okay, the best fit outcome it could give me. Then only we are preparing that data to build the machine learning model or to build a AI model, right? So when we are creating a AI model based on the data that we have, we are just choosing the correct algorithm for it. After that, we are doing the when we are choosing the AI model, okay. So after that, what we are doing, we are passing some algorithms, some machine learning algorithms. Then it will give me the output. After so many trials, okay. When we are training our data set, so we are training with the by changing different kind of parameters. We are doing the hyper tuning, okay. Then after that only it will give us the best possible result, right? So when we are implementing a machine learning model, or just take an example of a development environment, okay, of a project. So first instance, what what is happening? Suppose there is a developer one, okay. Suppose there is a developer one who is who has done the project, okay, who has done the development, the environment, who has created the development environment in his Windows. Okay, in the Windows machine, he has created one development environment. He have installed some packages like suppose he have installed some Anaconda, he has some installed MySQL database, NoSQL database. Okay, he have installed some libraries, okay, some requirements, some modules, some packages for the deploying of that project. Okay, what is the requirement? What are the configuration needed to develop that project? He has done in his Windows operating system in his laptop. So after some days, what happened? The developer two has come. Okay, he has joined the company, and when he is creating the development environment, suppose he have the Linux operating system. Okay, so when he is just continuing with the same project. So what he have to do? He have to again install he have to again do the installation for what are the necessity packages, what are the necessity modules, what are the requirements, what are the configurations in its Linux machine. Okay, so at that time, what happened? When the installations, when the configuration are done in another machine, okay, by another person, by the developer too. So this at this point of time, what happened? Now some libraries are getting missed. Some libraries will missed. Some requirements may not be he haven't that much access, or sometimes he have missed that. Because there are very when we are doing a project, there are very minute installations, there are very minute packages are there, which we have to be careful. Otherwise, our project will not run. Our development environment will not create, and it will not get fitted into that environment. Okay, when we will run the project, it will throws us the errors. So suppose, okay, then the developer too has created the environment, but at that time, what happened? Now, due to the lack of some libraries while creating the developer environment, the project is unable to run in its system. Okay, so at that time, so in some case, the developer one has uh, helped the developer to finally install the all the packages. Okay, all the installations. He have helped them for doing all the installations, all the configurations, okay, all the requirements that has been done for the for that project to run that project. So the developer one has completely helped the developer to run it. Okay, so this developer part was completed. So when the project was developed, when the project was created, at that time, what happened after that? After that, the development project was sent to the QA environment. Okay, the testing environment. QA is nothing but there is one tester sitting with the QA server. Okay, sitting with the QA server. So when this project, when this project was sent to the QA server or the QA person, so at that time, what happened? Also, the person sitting in the QA server, he also have to install the same packages again, the same dependencies, the same configurations. Okay, what are the requirements that is necessary to run that project? He again have to install in the QA server. Okay, we have a different QA server. So in this part, what happens? Suppose he might miss something, he might miss some dependencies. It always happens. Okay, it always happens. So then the QA tester who is sitting over the QA server, what he will tell that okay, developer one, my the project is not running in my system. Okay, what kind of project you have developed? It was not running in my system. It is not running in my system. It is showing me the error. Then at that time, both the developers, what they will say that what is the issue? It is completely means fine. It is completely running in our system. We have developed it is completely running. So this will create a war between the developers and the tester. Okay, and for these issues, the project will crash somehow maybe. Otherwise, it will take more time. Okay, it will take more time to resolve the issues. And I will tell you one thing, as per my experience, installations are the most painful thing. Okay, installations are actually these are the most painful thing. It will take. Means somehow we have to install some small packages. It's okay, but when if we are doing some installation like Anaconda, some installation like MySQL Server, okay, so at that time what happens? It consumes time. It depends on our network and also it consumes the time. So we don't, it's like in a one day or for a, suppose a project duration is like 15 days. Okay, the client has given the duration that okay, in 15 days only I have to you have to submit me the project. So when we are developing the project, there are so many things. There are so many things. We have to write the code, we have to do the testing, we have to create the developer environment, we have to install so many dependencies. Okay, and most of the things we have to write the logic for that. Yes or no? So for this, to resolve this issue, container come into picture. Okay, container come into the picture. So what does this container do? Now, whatever the dependencies are there, suppose I want to for my project, um, installation of Python is necessary. Okay, so installation of Python is necessary. So installation of some other tools are necessary. The MySQL database is necessary. So whatever necessary installations and configurations are there, what they will do, they will just put it in a container. Okay, they will just put it in a container, and this container, what it will give you, it this container will run in the developer environment. Okay, this container will run in the developer environment. And also, when after running in the developer environment, you have to pass it to the QA server for the testing, right? For the testing purpose of that project. So when you are sending the when the project will be sent to the QA server, at that time also, if this container, okay, this container will get sent to the QA server. Okay, this container will send to the QA server. What they will do, they will just unwrap the container. Okay, they will just unwrap the container. Unwrap the container means what? They will just open the container. Okay, in the software terms, we call it as the unwrapping it, wrapping and unwrapping. Okay, so it will just they will just open the container and run the container there. So this what it will give the benefits. Now there will be no chance of missing any libraries installation or any requirement installation of that project, because whatever the necessary installation has been made, that all the installations and configurations are stored in this particular container. Okay, you just have to move that container to the different server and you have to just run it. Then whatever the tools, whatever the packages are inside the container, it will completely get installed. Get it? And also this container can be passed to the production environment after the QA testing. If the project is completely running fine, then what happens? It will move to the production environment. Okay, so when it is moving to the production environment, also at that time, we will just sit that container to there, they will unwrap it, and they will run the project. Okay, so if we will talk about the complete life cycle of the project, this is the one. We have to do the installations, we have to create the developer environment in which we are developing our project. After the development of the project, then it will be sent to the QA environment for the testing purpose, that whether the project is running fine or not. Getting? Then if the project is running fine, everything is okay, it will send to the development production environment for the further process. Okay, then it will launch in the market. And it will be displayed to the client. It will hand over to the client. So here what happens? There will be no issues with the dependencies or no issues with the installations. Okay? If we will talk about the Docker, so the Docker is nothing but it is a container. Okay, so Docker is nothing but it is an open platform for developing, shipping, and running the applications. Okay, so this enables you to separate your applications from your infrastructure so that you can deliver the software quickly. And with this Docker, we can manage the infrastructure also in the same ways we manage our applications. In the way that we are managing our application, how we are installing the application like Anaconda or any kind of application, suppose XAMPP or some SQL database or MongoDB, whatever installation we are doing, or some visualization tools or something. So whatever app installation, whatever applications we are installing, but and the infrastructure is the will be the same. So by taking the advantage of the Docker's methodologies for shipping, for the testing, for the deploying code quickly, we can significantly, what we will reduce? It will reduce the delay, right? It will reduce the more time consumption between writing the code and running it in the production environment. It will save your time more. Okay, because as I have told you, before writing the codes and all, before writing the logics for that project, you have to install the dependencies. And this will take the time. This will take much more time. And if that is continuing in a loop, in a developer environment, it has to install them. Again, for the QA environment, it has to install them. Again, for the production environment, it has to install. So it is completely running in a loop, right? And it will take more time. Also, if many times your project is showing the error, it is not running properly. So at that time, what happened? Due to the execution time errors or due to the runtime errors, sometimes the project may crash. Okay, this also happens. This also happens in some condition. So this Docker provides the ability to package and run the application in a loosely isolated environment called a container. Okay, so the isolation and the security that is there to that allows us to run many containers simultaneously on a given host. And these containers are lightweight and contain everything that needed to run the application. Okay, so if you will talk about here, it is the Docker engine, then it is nothing but it is a portable, lightweight application runtime and packaging the tool. And in the Docker, we have two things. One is the Docker engine, and second one is the Docker hub. So Docker hub is nothing but when we are deploying something in the cloud. Okay, it is a cloud service for sharing the applications and automatic workflows. Okay, when we are sharing the applications in the cloud, along the cloud, up in the cloud. So at that time, we need the Docker hub. Okay, now if you will see the Docker architecture here, the always remember in the Docker there are two things. One is the Docker image, and another one is your Docker container. Okay, so suppose take an example. Whenever we are building a container, okay, whenever we are creating a container by installing all the dependencies and configuration inside it. Yes or no? So what we have to do when we are giving the when we are creating the container, okay, when we are creating the application environment there, so we have to dockerize it or we have to containerize it. Okay, we have to dockerize it or we have to containerize it. After that, what it will do? Now it will create a container that contains the layers of Docker images. Okay, that create the layers of Docker images. Suppose suppose in the base layer, okay, in the base layer, we were in the base layer there is the Linux present. Okay, we are working in the Linux. The project will work will get developed in the Linux. So in the base layer there is the Linux present. After that we have the Python 3.7. a 3.10. After that, we have installed the Anaconda. After that, some libraries in the top of the we are installing some database like MySQL or NoSQL database. Okay, so what happens in this case? So this Linux will stored in store is it is stored it in a layer. Okay, then after that the Python, then after that the Anaconda. So this will create an image. Okay, this will create an image inside the container. Okay, this will create a layers of image inside the container, and this layers of image is known as the Docker image. Getting? So this layers of image is known as the Docker's image. So if this is the container, look at here. Suppose this is the client. Okay, here we have Docker build, Docker pull, and Docker run. We have three methods. Okay, and this is the Docker host, where the Docker daemon is present. Here it is the containers are there. It is the first container, it is the second container, it is the third container. Okay, so in the first container, suppose we have what? We have some OpenStack, we have some MongoDB, we have some in this layer, in the very base layer, we have the Linux or the OS environment. Getting? So these are the Docker images. These are the Docker images. And when this Docker images, okay, this Docker images, when they are processed to run the application environment, to run in the application environment, okay, so when this Docker images, what they will do, when they will run, they will create an application environment. And this application environment is nothing but this is the container. Okay, this is the container. Getting? So this is the difference between the Docker images and the Docker container. Docker images are nothing but what are the installations, what are the applications that you have stored in the application environment that you want to install. Okay, it will just create a layer. It will just create a container, and inside that container, it will create a layer of images. Okay, and when this layer of images are pushed to run, after running, it will create the application environment, and this application environment is nothing but it will ship to the container. Get it? So Docker platform, we have discussed now that it provides the ability to package and run the application in a loosely isolated environment. Get it? So the containers are lightweight and it contains everything that needed to run the application. So we do not need to rely on what is currently installed on the host. It is completely independent of the installations of some other applications in the host system. Okay, so you can easily share these containers while we work, and be sure that everyone we share, they will get the same container that works in the same way. So whatever whatever container you are sharing, okay, you are sharing for the project to the QA environment or to the production environment, always remember the container should be same. For one project, if one container you are building with some installations and the dependencies, so that container should be passed. Only that container should be passed to the QA environment and after that to the production environment. And the workflow must be same. Otherwise, your project will not run. Okay? The project will not run. So if I will explain the container in a very layman way, in a very simple way. So the containers are nothing but it is the way to package the application with all its necessary dependencies and the configuration. Okay? So it is a portable artifact which is easily shareable and movable package to any environment. And what does it do? It makes the development and the deployment more easier and efficiently. Okay? So it is a very nice thing when we are nowadays when we are dealing with more data. Okay, when we are getting the n number of projects. So at that time, because in one team I think 5 to 7 members are working. Okay, someone is developing the front end part of the website of that project. Some is developing the back end. Someone is developing the suppose some APIs to APIs. Someone is trying to connect their project. Okay, so all these things. Someone is tasting it. Someone is in the production environment. So it is when we are doing a project in a team. So we have around 4 to 5 persons, and each and every persons are given different type of work. Someone is doing the analysis part. Okay, so if I am talking about the Docker architecture, then the Docker uses a client server architecture. Okay, the Docker always use the client and server architecture. So this client, what it will do, it will talk to the Docker daemon. It will talk to the Docker daemon, which does the heavy lifting for building, running, and distributing your Docker containers. So what does this Docker daemon do? It does heavy lifting of building, running, and distributing the Docker containers. Okay, the Docker containers, it is responsible for that. Then the Docker client and the daemon, these two, the client and the daemon can run on the same system. These two can run on the same system, or you can connect this Docker client with remote Docker daemon also. Okay, so these two maybe work in a same environment, in the same system also. Also, the client is so in the it is suppose the client is in the host system, and you want to use the Docker daemon in some other in some remote server, in some remote host, you can do it. And this Docker client and daemon communicate using a REST API. Okay, these two communicate by using a REST API. So over the Unix sockets or a network interface. And another Docker client is the Docker Compose. We will talk about another Docker client. So it is a Docker Compose that lets you work with the applications consisting of a set of containers. Okay, so if you will talk about the Docker daemon, so it listens for the Docker API request. Whatever the Docker API request comes, okay, the Dockerized container, whatever the API request comes, so it will listen for it. It will manage the Docker objects such as the images, the containers, the networks, and the volumes. Okay, so basically the Docker daemon is nothing but it is the Docker host. It is the main part of the Docker. The whole system, it is the main part. And a daemon can also communicate with other daemons to manage the Docker services. Okay, so now what is the Docker client? The Docker client, it is the primary way, it is the first and foremost way that many Docker users interact with the Docker. Okay, so when you use the commands such as Docker run, okay, to run the Docker, so the client, what it will do? The client sends these commands to the Docker, which carries them out. Okay, whoever Docker is present there, what it will do? The client will send this command to them. Okay, and the Docker command uses the Docker API. So whatever the command we write in the Docker, it uses the Docker API. And this Docker client can communicate with more than one daemon. Okay. So now coming to the registry. What does this mean? So this Docker registry. It stores the Docker images. Whatever images, this images is nothing but what are these? These are the applications or these are the installations. These are the configuration. These are the libraries. Okay. Whatever dependencies we have for our project, these all are nothing but these are all are the images here. So what does this registry do? This registry will store this Docker images. Okay. And always remember the Docker Hub is a public registry that anyone can use. Okay. It doesn't have any kind of encryption. Okay. And it doesn't need any kind of authorization. Anyone can use this. And the Docker is configured to look for the image on the Docker Hub by default. Okay. You can even run your own private registry. It doesn't matter. Get it? Now, coming to the next part, that is the Docker versus the virtual machine. And it is very important to understand the difference. It is very important because when you are working with a Docker, then you have to means you have to understand that okay, what is the Docker and what is a virtual machine, because many people get confused. Okay, and due to the workflow, okay, the work of both the Docker and the virtual machine is same. Okay, means somehow same. There is a very little difference between their work. Okay, so now come to the topic that what is the difference between the Docker and the virtual machine. So when we are talking about a system, okay, when we are talking about the operating system, so we have three layers. First one is the hardware, the base one. Okay. Second one is your kernel. It is your operating system kernel. And third one will be your application layer. Yes or no? So, if we are talking about the container or the Docker, okay. So, have you ever listened about the in the Linux? In the Linux, we have different versions. Like we have the Red Hat. Okay, we have the Red Hat Linux. We have the Ubuntu Linux. Yes or no? So, what happens in the what is the minor changes in this both two in the Red Hat and Ubuntu? Here here just does the system UI changes. Okay, here only the system UI changes. Okay, and this system UI where it has changed, the changing of this system UI, okay, the UI user interface, the what is the application layer is responsible for that. Okay, that whatever the changes is making here or has made here, it happens in the application layer. Okay, so when we are talking about the Docker, always remember the Docker what it will do when it is get installed in your system. Okay, when you're creating the container and all, so the Docker image will virtualize the application layer. Okay, the Docker image what it will do, it will only virtualize the application layer. Okay, it will only virtualize the application layer of the operating system. Getting? But if we will talk about the virtual machines, when we are installing a virtual machine to our system, what it will do? So it will virtualize both the application layer and the OS kernel layer. Always remember, when we are installing any virtual machine, so virtual machine has its own application layer and kernel. Okay, it has its own application layer and it has its own kernel. So it will completely virtualize your system's application layer and the kernel layer. Okay, a complete subsystem is installed in the host system. If you will install the virtual machine, so it is nothing but it is a complete subsystem which will get installed in the host system. Getting it? So this is the major difference between a Docker and the virtual machine. Okay, so if we will talk in a, this is the very means a basic way that I am making you understand. If I will talk in the bookish term, so for our understanding, so both the virtual machines and the Docker container, it what they will do, they will provide the isolated environments to run application. They will provide a different environment. They will provide a virtual environment to run the applications. But what is the key difference between these two? The key difference between these two is in how they facilitate this isolation, how they're affecting the host system, how they're facilitating the whole isolation. So the VM boot, suppose just take an example, recall that a VM boots up its own guest OS. Okay, so it has its own kernel. It has, suppose we are doing it in a operating system in the OS window. So it has its own OS kernel. So therefore, what it will do, it will virtualize the both the operating system kernel and the application layer. But when we are talking about the Docker container, it will virtualize only the application layer and whatever whatever application we are running inside the Docker, so it will run on the top of the host operating system. Okay, it will run on the top of the host operating system. So this is one of the difference. Second, if you will talk about the advantages between the Docker and the virtual machine. So always remember the Docker images size is usually smaller. Okay, this Docker image size is usually smaller as it is running on the top of the OS layer, on the OS kernel layer. So the images, the size is usually smaller. Get it? And the size is smaller. It's like in some MBs, okay, in some megabytes, the size will be there. But if you will talk about the virtual machine, the virtual machine size will be always large because it is completely virtualizing, it is completely building a subsystem in the host. In the host system, it is completely building a subsystem. Okay, then coming to the next, in the Docker containers, if it will start, if you will do the compatibility, okay, if you will do the compatibility between the Docker and the virtual machine, so the virtual machine can be installed on any operating system, whether it is the Windows or it is the Linux or it is the Mac. Okay, so the virtual machine can install on any operating system, but but the Docker images has the compatibility issues. That means what? Now, suppose we are creating a Docker. Suppose we are creating a Docker in a Windows. Okay, in the Windows operating system, we have created one container over there. We have Dockerized it. So that container that we have created in the Windows operating system, that can't be run on the Linux operating system. Okay, if the operating system changes, it will show the compatibility issues and it will not run in the another operating system. Okay, but for the virtual machine, it can run on any operating system. Why it will run on any operating system? Because it will virtualize the operating system of the host, in which server it will work, in which operating system it will get installed. Suppose mine is OS. Okay, another person is there who have the Linux operating system. Suppose I am here installing the virtual machine. So what it will do? It will completely virtualize my system. Okay, it will completely virtualize my application layer and my operating system kernel. And if the operating system kernel is getting virtualized, then obviously the virtual machine has its own kernel, right? So it can easily run on my system. And it will get installed in the Linux. What it will do? Obviously, it will virtualize the Linux kernel. The Linux OS kernel, it will virtualize. And it can easily communicate with the hardware. It can easily run the application, run any application on the top of the application layer. That is, so this is the advantages, or these are the main difference between a Docker image, between the Docker and the virtual machines. Okay, and one more thing, the Docker container starts and run much faster. Okay, as it is totally as it is totally based on the application layer. Okay, the virtualization is done on the application layer, so it it always starts and runs much faster than the virtual machines, because virtual machine has to do a lot of the things. Okay? So if we will talk about the security, the Docker containers run on the top of the host operating system. Therefore, if the host OS is suspectable, suppose there are some catches, or there are some issues in the operating system kernel. Okay, to security vulnerabilities like things. So this will not affect the Docker containers. Okay. But in the virtual machine, what will happen on the other hand? It will boot up their own operating system and are more secure. So each virtual machine is a fully blown machine running inside another. If you have the stringent security constraints to be met for the sensitive applications, you should consider using a virtual machine instead. Okay, if your project is big, if you want to run a very highly demonstrative project, then for that you have to use a virtual machine, because otherwise, suppose it will not get to it. Okay, so this is the difference between a Docker and the virtual machine. So here we have the slide for the Docker images and the Docker container. As I have told you, this is the Docker file. Then if it will build it, then it will build the images. It will form the Docker image, and when we will run this Docker image, it will form the Docker container. Okay. Now, what is the use of the Docker? What is the use of the Docker? So it is the tool, as we have discussed, that it is a tool for creating It is a tool for creating and deploying the isolated environments for running the applications with their dependencies. Yes or no? So this basically Docker makes it easy to write and run the code smoothly on other machines with different operating systems by putting together the code and all its dependencies in a container. Okay, and this container makes the code self-contained, independent from the operating system. What is a container you are making or you are passing? Always remember, this container, what it will do, it will make the code self-contained. Okay, it will not dependent on the operating system. Okay, independent from the operating system, whatever code it will make, it will just self-contained it. Okay, so the main thing, what are the main thing we have in the Docker? So the main terminology, we have the Docker image, the Docker file, and the Docker container. So the Docker container is nothing but this is the container which is a runnable instance of an image. Okay, and you can create, start, stop, move, or delete a container using the Docker API or the CLI. Okay, and what is the Docker file? The Docker file contains all the code to set up a Docker container, from downloading the Docker image to set the environment. Okay, it contains all the setup codes. This Docker file. Okay, this Docker file contains all the setup codes. And if you can think of it as describe the complete operating system installation of the system that you want to run. Okay. Now, what is the use of the Docker in the machine learning model deployment? Whatever we have discussed till now, from that point of discussion, you must have gained some ideas that okay, why we will if you are using the Docker in creating some project, in developing some project, then what is the why we are using the Docker, why it is important to use the Docker in the data science. You must have gained a little knowledge from that, from this discussion. As I know. Okay. So why we will use this? This is my Jupyter. Okay, this is my Jupyter notebook. And in this Jupyter notebook, what I am doing here, this is the okay, this is my Jupyter, this is my host machine. Okay, focus on this now. So here we have the TensorFlow. Okay, it is the container. We have the TensorFlow. Okay, then we have the Keras, we have the scikit-learn, we have the Hotboard, we have the Pandas, we have the NumPy library, OpenMPI, SciPy, okay, Python, and others. These all are the dependencies, all other libraries that I want to install. Then I'm giving the CPU. Okay, then I'm also running the GPU because for the machine learning project, for the deep learning project, all in terms in all together, if I will say for the data science project, we need the GPU. Okay, we need the GPU. Ready? So this GPU, what it will do? It will make our project or it will help us to run our project even more smoother, and GPU is nothing but what? It is the graphical processing unit, right? Yes or no? So what it will do? It will give us the more enhancements. Okay. So whereas as the GPU is a specialized component that excels at running many smaller tasks at once. Okay. But if we will talk about the CPU handles all the main functions of the computer. Okay, and this CPU and GPU, these are both essential. Okay, these are both essential to run the project. Get it? Now, so with this images plus the code. Okay, here what I am doing, I'm just creating the container here. Okay, now here we have the data sets and the checkpoint that will mount over it. Okay, that will mount over it. And after creating this Docker image, when we are passing it for the run, when we are running it, it will create this container. Okay, along with the Docker images, along with the code. And what I will do, I can just shift it to my any Jupyter environment. Okay, any Jupyter, any system, any Jupyter any system Jupyter notebook. Okay, I can run it also. Getting so we are running our machine learning models in the Docker containers. Okay, that will bring a number of benefits. Meaning that will bring a number of benefits. And what are the benefits? The first benefit is the reproducibility. That means once you have tested your containerized application, okay, once you have tested your containerized application, you can deploy it to any other system where Docker is running. Okay, and also it can be shown that the application will perform exactly as it did when you tested it. There will be no difference. There will be no such error will arise if you are using the Docker container. Okay? So second one is the agility. The portability and the performance benefits that is offered by the container can help the data scientist make their development process more agile and responsive. Okay, it enhances the continuous integration and the continuous delivery process. Ready? If we will talk about its portability, this means that the moving from the local development to a supercomputing cluster is easy. We can also use this container over the cloud. Okay, we can also move this container from a local development system to a supercomputing cluster also. And at that point of time, we can also avoid the setup hassle. Okay, the setup, the code setup or the application setup. Okay, this hassle will also not be there. So how we will start with the Docker? How we will start with the Docker? We have some like we have to install the Docker. Okay, we have to install the Docker. Then what we have to do? We can install it from its official website. Okay, that is the Docker website. Then and always remember when we are installing the Docker. Okay, when we are doing the installation, uh, there will it will ask. First of all, it will ask for your operating system. Okay, on which operating system you want to install it. But after that, what it will do? It will ask you for your system requirement. Okay, it will ask you for your system requirement, and this is the main thing that came into picture when we are using the when we are installing the Docker. Okay, there is nothing so much fancy in that. You just have to check your system requirement according to the documentation that has been listed in the Docker website. Okay, that has been listed in the Docker website. Suppose let me show you that part. Just give me some time. I will show you that part. I will do a new share now. I will use this one. Okay, my screen is visible to all of you, I guess. So if I will go and check for the Docker. So this is the Docker website. Okay, this is the Docker website. Okay, now here it is providing the download Docker desktop for the Windows. Okay, download Docker desktop for the Windows. If you will go and check here, so it developed the faster run anywhere. Okay, the most loved tool in Stack Overflows. Okay, this is the reviews they have given. So here we have to accelerate how you build, share, and run the modern applications. So it has been given that they have provided documentation that the Docker makes the development efficient and predictable. Okay, all the things we have here. Getting so now if we are using the here some of the tools and the images are given like the Bitbucket, we have the Circle CI, the Elastic, the GitLab, okay, the JFrog, Kubernetes, MongoDB. Okay, so this is nothing but this is a what? This is a NoSQL database. Okay, this is a Visual Studio Code. We all are means familiar with this Visual Studio Code also. Okay, so this many things they have given. Okay, now if you will go and here you have the download option. Okay, here it is for the Apple chip, Linux, and for the Intel chip. Suppose if I will go and use the download option here, it will directly download. Okay, so don't go for the direct download option. It will show you the dependencies. Okay. Okay. So just go with the get started here. When we will click on the get started, what we'll do? So learn how to install the Docker, and here we have the extensions. Here we have the download for Windows, for Mac Intel, for Mac Apple chip, for the Linux. So if I will go and use for the here they have given some documentation, not an issue. If I will go and download for the Windows, so now it will Show me. Wait a second. It is taking some time. Not an issue. I have told you that installation will take some time. So now, actually, I think my system requirement is completely okay for this download, for this installation. So if I will use the, here we have the documentation. Okay, if your system requirement is completely fine, your download will be successful. Not an issue, your installation will be successful. Now, here we have the documentation. Okay, so the Docker desktop, we have to use the Docker desktop. Okay, not the Docker hub. The Docker hub is for the cloud deployment. So for the local environment, for the local project environment, we have to use the Docker desktop. It will not be an issue. So this Docker desktop, what it will do, it is a one-click installation application for your Mac, Linux, or Windows environment that enables you to build and share the containerized application and microservices. Okay. So here we have all the documentation of this. Okay. Install the Docker desktop, explore the Docker desktop. Okay, all we have here. So if we will go and check the, where it will go. Okay, it will not here. Maybe they have just updated their website. That's why we can't see the thing that is the system requirement. I just want to give you that knowledge. Okay, so understand the permissions or the requirements for the Mac. Okay, so this is for the Mac. This is for the Windows here. Okay, so here the system requirement is there. Always remember, always read the system requirement before using the Docker. Okay, so it is giving the WSL2 backend. So here what it has given. Okay, it has given for the Windows 64-bit, Windows 11, and Windows 10. Okay, for the higher enterprise or the education. And what are the following hardware prerequisites required to successfully run under WS2 on Windows 10 or Windows 11? So your system must be of the 64-bit processor. Okay, it should contain the 4 GB system RAM. It should be the 4 GB system RAM. Then the minimum requirement is a 4 GB system RAM. Then the BIOS level hardware virtualization support must be enabled in the BIOS setting. Okay, so if you will go and search for the BIOS level hardware virtualization if you will go for the BIOS setting in your system, okay. So at that point in that setting, so this BIOS level hardware virtualization support must be enabled. Getting it should be enabled. So these are the system requirements. And always remember, if you have the Windows versions like means that is 10, okay, the older versions, okay, if you have the older version, then at that point of time, what will happen? The Docker will not support. Okay, it can't run in your system. So what at that time, what we have to do? We have to separately create a virtual machine for that, a virtual environment for that. Okay, we have to separately create the virtual environment for that, and that virtual system, that virtual machine system, we have to install the Docker. We have to give the environment. We have to give the path, the environment of that particular virtual machine that we have installed in the host system, and after that only it will run. Getting? So this is the complete information about the Docker that I have provided you. Okay, if we will talk about the we will talk about the benefits. Okay, so here are the benefits. That is, the Docker is better suited for the microservices approach and the agile development. So it enables more efficient use of the system resources. Okay, it enables the application portability. It enables the faster software delivery cycles. Okay, so here it is the Docker daemon. Here it is the REST API. Here it is the client Docker CLI. Okay, if we will talk about the practical use cases, then it is used for deploying the software. Okay, it has the running lightweight Linux distros. It will run the lightweight Linux distros. Then as the Docker containers are very lightweight, so they are robust enough to be used for hosting the server utilities. It can create the custom Linux images. Okay, so these are the basic benefit of the Docker. So this is all about today's topic. Okay, so from these 2 days of orientation session, we have gained the knowledge about the AI, the machine learning, then how the project, what is the life cycle of the project, okay, how we are using the Docker in the project, yes or no? So if anybody has any queries, you can ask me now. Otherwise, I will wind up the session and we will meet we will meet up in the next session of having some uh, interesting topics about the data science. In the data science or in the AI, we will meet up with some exciting topics in the next session. Okay, so I will stop the recording now. Thank you everyone for joining the session and have a good day.